Alright class, in this lesson we're going to take a look at solving a quadratic inequality by using test numbers. First of all, let's notice it's an inequality because it's not an equal sign. There's a greater than, or it'll be less than or equal to sign. So our first step is actually to make it equal to 0. Because we're used to solving things that are equal to 0, so we're just going to kind of ignore the inequality sign until later. Okay? So we can rewrite it. X squared minus x minus 12 is equal to 0. And we want to solve it like we were solving inequalities before, which was that we would solve by factoring the magic x. So we put a negative 12 here, put a negative 1 on the bottom, and then we figure out what multiplies to be negative 12 that adds to be negative 1. And here it turns out to be negative 4 and 3. And then we take our 2 and cut that in half and divide both these by x. And we get, and by 2 I meant the x squared. Then we get x minus 4 times x plus 3. And that's equal to 0. And then we continue to actually solve. So step 2 is to solve. Okay? And we get x is equal to 4 and x is equal to negative 3. Now we actually come back to our original equation, the x squared minus x minus 12, and we're going to have to use what we call test points. So step 3 is to use the solutions to make test points, so we use our solutions as boundaries. On the number line. So what that means is I need to draw a number line and put my two solutions here on it, which would be negative 3 and 4. Okay? And we go back to our original equation now, which is the x squared minus x minus 12, which is bigger than 0, and we figure out where things actually work. So here's the problem, is that negative 3 and 4 are not actually answers, because if you notice, it's supposed to be bigger than 0. Well, we just showed that these would cause it to be equal to 0. So that means that those aren't actually answers. What are answers are the things that cause it to be bigger than 0. So we need to figure out where that happens. And that happens either to the left of negative 3, between negative 3 and 4, or to the right of 4. And we figure that out by picking a point to the left of negative 3, like negative 4, or negative 5, negative 6, negative 20, it doesn't matter. Picking a point between negative 3 like 0, or sorry, between 3 and 4, negative 3 and 4 like 0, or to the right of 4 like 5 or 10 or something like that. I'll pick 5. And all we have to do is take those points and plug them into this equation and see if that answer is bigger than 0. Now we don't actually care what those solutions will be, we just care if it's positive, if it's bigger than 0. So if I plug in like negative 4, I'm going to get 16 minus negative 4 minus 12. And if I change these signs, you'll notice that this answer will be positive. It'll be positive 8, but we just care that it's positive. Positive is bigger than 0, which means this area is true. It works. In other words, I have solutions over here. All those numbers to the left of negative 3 will cause this to be a true statement. So now we need to try at 0. So if I take 0, so I'm going to plug it into this equation and make it 0 squared, which is 0 minus 12. Well, that works out to be a negative. A negative is not bigger than 0, which means this area is false. It does not work as part of your solution between negative 3 and 4. So now we try our final right area, which is at 5 here. So I plug that in my equation, get 5 squared is 25 minus 5 minus 12. And if you work that out, you'll end up getting 8 again. Positive 8 is what you care about. Positive, which is in fact bigger than 0. So this area is true also, which means that I have solutions over here. So what that means is your answers are where I have shaded. To the left of negative 3, to the right of 4. Now we just have to learn how to write it. We write that as a set. Well, there's two ways I can write it. I can say, okay, well, x is everything smaller than negative 3, or everything x is bigger than 4. Okay, but we want to write that in a set notation. The set notation goes from negative infinity with parentheses up to negative 3 with parentheses, and then from 4 all the way over to infinity with parentheses. And then you put this little U symbol for union. That just means or. So the parentheses, if you recall, mean that it doesn't actually touch that point. Like negative 3 has parentheses instead of a bracket. A bracket would mean it could actually touch negative 3 and that it would actually be a solution there. But because it says that it can't be 0, 3 didn't work and 4 didn't work, because when I plug 3 or 4 in, they actually cause it to be 0, and it's got to be bigger than 0. So this is the way that you want to write it. This is your solution. So let's take a look at some special cases. These special cases are ones that I don't actually want to start solving or setting it equal to 0 first, because I actually want to think about the fact that when can I square something and have it be bigger than a negative 1? Well, any number I square will turn out to be positive. Anything you square times by itself, it'll turn positive. Well, that's always bigger than a negative, which means this is always true. If it's always true, that means you have infinite solutions. We can write infinite solutions by writing negative infinity to positive infinity. So these ones are nice because you know how they work. The key is noticing that it's actually a special case and actually thinking about it before you do the problem. The second one is similar. Anything you square is always positive, and that is never smaller than a negative 1. So this is not true, this is false. If you have a false statement, then it's no solutions. And another way to write no solution is the null set, which is a 0 with a line through it. Okay, so these are two special cases. And now we'll look at one more example that's similar to the first one. But this one is actually a third degree polynomial. And all that means is that if I multiplied this actually out, I would get x to the third power. That's third degree. But we don't care about that. We care that we need to have this inequality first set equal to 0, just like the first problem, and figure out my test points. So set it equal to 0, that's your first step. And so I'll get x, well, I'll just write it right here. If I said it was equal to 0, I would just write x minus 1 equals 0, x plus 2 equals 0, and x minus 4 equals 0. Okay, so because they're all multiplied, that's the zero product property, which means my step 2 to solve, I would get x equals 1, x equals negative 2, and x equals 4. Now these are my test points. So my third step is to write your number line with your test points on it. So I draw my number line. My test points are negative 2, 1, and 4. Okay. So now what I'm supposed to do with those test points is, with my check, these are actually like my boundary points. Okay, I actually need to test between, to the left, to the right, and between them. So I need to figure out if something over here to the left of negative 2 checks out, look between negative 2 and 1, look between 1 and 4, and finally to the right of 4. So that means I need to pick a point like negative 3. I need to pick a point like 0, a point like 2, and 5. And I need to check them in the original equation, which before I wrote over the inequality symbol was less than or equal to 0. In other words, I need to plug into this equation x minus 1 times x plus 2 times x minus 4, and I'm looking for things that make this less than or equal to 0. In other words, I'm looking for negative numbers. If my solution when I plug it in is negative, I'm good to go, and that area, that region of the number line will work. So I'm going to start here, over here at negative 3, and I'll plug that in right for my x's. So I'm just going to erase my x's and plug it in and see what happens. So I plug in negative 3. If I plug in negative 3, negative 3 minus 1 gives me a negative. Yeah, I don't even care that it's negative 4, it's just negative. Negative 3 plus 2 gives me a negative, and negative 3 minus 4 gives me a negative. I just care that they're negative. I multiply them together, and that gives me a negative. And any negative is less than or equal to 0, which means this area actually checks out. This is part of my solution. Okay? So now we're going to try the next one. So I'm going to erase this part and plug in my 0. Well, if I plug in my 0, I'm going to be left with negative, positive, negative. And if I multiply that out, that'll turn out to be a positive. A positive is not less than 0, which means this area over here fails the test. So that is not part of your solution. Okay, so now I keep going, and I want to try my next point, my 2. Now again, you could pick any point. You could pick 2, 3. You could pick 2.5 if you wanted to. But I like to keep it easy as possible. 2 minus 1, let's use a different color. 2 minus 1, 2 plus 2, and 2 minus 4. So if I plug this in, I should get a positive, and a negative. When I multiply that out, that actually equals a negative, which means that is actually less than or equal to 0. So this area checks out, it's true, so I can shade it to say that that's part of my answer. So now finally I'll just plug in my 5, and when I plug my 5 in, I should end up with a positive, and a positive. When I multiply that out, that is positive. It does not work, it fails. So I have two regions where my answer is. I have from negative infinity all the way up to negative 2, and I put a parenthesis at negative infinity because you can't actually touch it, a bracket at negative 2 because you can touch negative 2, and then from 1 to 4 with brackets. And I use the union symbol because you can actually have it in both those places. Now again, the reason why you have brackets is because you can, when you plug in negative 2, plug it in and it actually will be equal to 0. So it actually works. When you plug in 1, it's actually equal to 0. Plug in 4, it's equal to 0. So we can touch those points. So use a bracket rather than a parenthesis. Okay? And this is your final solution for this problem.